Look inside almost any furnace, fan coil unit, or small air handler built in the last 50 years and you will find the same part, a metal drum full of small curved blades that looks like an exercise wheel for a pet. The trade calls it a squirrel cage blower. Its proper name is a forward curved centrifugal fan, and once you understand why this shape took over indoor air, you also understand its limits. The name describes the rotor honestly. Dozens of shallow blades, each curved forward into the direction of rotation, arranged in a ring between two end plates. The middle is open, air enters the drum along the axis, turns inside, passes through the ring of blades, and leaves around the whole circumference. Watch a real one taken apart. The wheel itself is only part of the machine. Around it sits a scroll housing that collects the air flung from the whole circumference and funnels it toward a single outlet, and the wheel usually rides on a shaft between brackets with rubber-mounted bearings. On a double-inlet version like this one, air enters from both sides, which doubles the flow for the same diameter and keeps the wheel loaded evenly. Why did this shape conquer indoor equipment? Compactness is the headline. Because forward curved tips throw air out fast, the wheel moves a large volume for a small diameter, and equipment cases set the diameter. The second reason is quietness at low speed. A squirrel cage can move its air at modest RPM, and low tip speed means low noise, which is exactly what you want bolted to a bedroom wall or hidden above a ceiling. The mechanism has a price, and it is the same one every forward curved wheel pays. The air leaves the blades carrying most of its energy as velocity, not pressure. Converting that velocity into useful pressure is the scroll housing's job, and conversion always loses something. That is why this wheel type depends so heavily on its housing. Separate a squirrel cage from a well-matched scroll and its performance collapses. The second cost you have met before in this series if you have watched the blade type videos, the climbing power curve. The more air the system lets through, the more power the wheel demands, with no natural ceiling. Run one with the filter missing, or with a duct panel removed, and the motor current climbs until something protests. This is why furnace manuals are so insistent about closing the blower door. Now the failure that brings most owners to this machine, dirt. Those dozens of small forward curved blades are shaped scoops, and they collect dust, grease, and lint on their concave faces. A coating that looks trivial changes the blade profile, cuts the airflow, and unbalances the wheel. The classic symptoms, weaker airflow year after year and a new vibration hum, are usually just a dirty wheel, and cleaning it restores what looked like a dying blower. Cleaning it properly means reaching the concave side of every blade. Brushing the visible edges is cosmetic. The wheel usually has to come out, which is exactly why the removal video exists in this series, and why the balance of the wheel must be respected. Knock off a balance clip while cleaning and you trade a dirt problem for a vibration problem. Bearings are the other wear item. Many older units run sleeve bearings that want a drop of oil every season or two, and the first warning is a squeal or rumble at startup. Newer units run sealed ball bearings, quieter about their decline but not immortal. A bearing that has run dry grinds a shaft down fast, so the cheap moment to act is when the noise starts, not when the wheel seizes. Motors moved on even when the wheel did not. The same squirrel cage that once ran on a shaded pole or PSC motor increasingly rides on an EC motor now, same drum, same scroll, but continuous speed control and a large part load efficiency gain. If you have watched the EC video in this series, this is the classic retrofit case, the aerodynamics stay, the commutation changes. Should a new design still use one? If the space is tight, the duty is fixed and known, the pressure is modest, and the unit case is the constraint, yes, and millions are sold every year on exactly that logic. If the system resistance is uncertain or will change, or running hours are long enough that efficiency dominates cost, a backward curved wheel is usually the better ownership decision even where the squirrel cage physically fits. So the summary, a squirrel cage blower is a forward curved centrifugal fan, compact and quiet at low speed, dependent on its scroll, carrying a climbing power curve, vulnerable to dirt, and easy to modernize with an EC motor. If yours is misbehaving, describe the symptom, the unit it lives in, and the running hours, and we can tell you whether you are looking at cleaning, bearings, or a fan that was never right for the duty.